everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about the tutorial for the chapter 6 and the chapter 6 entitled Network Layer. So let me read first this one. Network applications and services on one end device can communicate with applications and services running on another end devices. How is this data communicated across the network in an efficient way? That question. So we hope that we answer that at the end of our video. So the protocols of the OSI model network layer specify addressing and processes that enable transport layer data to be packaged and transported. The network layer encapsulation enables data to be passed to a destination within a network or on another network with a minimum overhead. So this chapter focuses on the role of the network layer. It examines how it divides network into groups of hosts to manage the flow of data packets within a network. It also covers how communication between networks is facilitated. This communication between networks is called routing. So, so this one is the network layer. So the exchange of data. So network layer protocols forwarded transport layer PDUs between hosts. So let's see this one. So they have the addressing. The data will be in these layers. And then if it is in the transport, it will become segment. And if it is in the network, so it will become packet. And in the data link, it become frame. And lastly, in the physical layer. So it becomes a binary. Then it will be going here, then encapsulation, and then decapsulation again, and then going. So the data is already here. So this one, addressing end devices. End devices must be configured with a unique IP addresses for identification on the network. So uh, the end devices should have a unique IP address for them to be identified easily. So it needs to be unique uh, for them to easily identify. So next one is the encapsulation. The network layer encapsulates the protocol data unit or the PDU from the transport layer into a packet. So when it comes to encapsulation, so it uh, encapsulates from the transport layer into a packet. Then the routing, the network layer provides services to direct packets to a destination host on another device. So routing. So it is from this layer, network layer provides services direct packets to a destination. So from to the destination and to the other network. Decapsulation. Decapsulation. When the packet arrives at the network layer on the destination host, the host checks the IP header of the packets. If the destination IP address within the header matches its own IP addresses, the IP header is removed from the packet. So, if the data is already uh, reaches its destination, uh, the packets, the IP header is removed from the packets. So this one, encapsulating IP. So this one, uh, Transport layer encapsulation, the segment header, the data. Transport layer adds a header so segment can be reassembled at the destination. Then the network layer adds a header so packets can be routed through complex networks and reach their destination in TCP/IP-based network. The network's layer PD is the IP packet. The IP encapsulates the transport layer segment or other data by adding an IP header. This header is used to deliver the packets to the destination host. So, the characteristics of the IP protocol. So, they have here the connectionless. So, let's start with the connectionless. No connection with the destination is established before sending data packets. So, connectionless means that it doesn't have any connection uh, with the destination. Then the best effort. IP is inherently unreliable because packet is not guaranteed. So, uh, they said here that the packet the IP is unreliable because the packet is not guaranteed. Is that packet delivery is not guaranteed. So the last one is the media independent. Operation is independent of the medium. It means that independent, so they are the independent. So the medium for them is like copper, fiber optic, or the wireless carrying the data. So let's elaborate more the characteristics. So let's start again with the connectionless. So I said a while ago that the connectionless doesn't have connection to the destination area. So uh, the sender doesn't know if the sender is present, if the letter arrived, if the receive if the receiver can read the letter. The receiver doesn't know when it is coming. So just like this one. This letter uh, will be put here in the mailbox and this truck will deliver to the receiver. So this doesn't have so they don't know if our receivers is present here and this like this one. Then the receiver. So this one is the receiver. He doesn't know when it is coming. It is just known that uh, there will be a coming letter or data, but it is doesn't know when. Then IP best effort delivery. So it is an unreliable network there. IP does not guarantee that all will be received. Other protocols manage the process of tracking packets and ensuring their delivery. So the best effort. So they are doing their best effort to deliver it because since it is not reliable. So packets are routed through the network quickly. Then some packets may be lost en route. The IP media independent. It operates independently of the media that carry the data at lower layers of the protocol stack, as shown in the figure. So this one is the figure. IP packets can travel over different media. So it is from this one. So they can travel in the copper Ethernet, then in the copper serial, then the optic fiber, the copper Ethernet, and the wireless. So uh, they are independent. They can flow or they can travel in the different types of media. So this one, IPv4 packet header. First one is the version. Significant fields in the IPv4 header include the version. Contains a 4-bit binary value set to 0100 that identifies this an IP version for packet. So, in the IPv4, so it has a 4-bit binary value set. Then, differentiated service or diffserv or the DS. So, formerly called the type of service field, the DS field is an 8-bit field used to determine the priority of each packet. So it is an 8-bit field that to have to identify the priority of each packet. Then the time to leave contains an 8-bit also by bit binary value that is used to limit the lifetime of a packet. So it says here that it is to limit the lifetime of a packet. Then the protocol. Field is used to identify the next level protocol. Then the source IPv4 address contains 32-bit binary value that represents the source IP address of the packet. So it contains 32 bits binary value. Then the destination IPv4 address contains a 32-bit also, and that represents the destination IPv4 address of the packet. So the source IPv4 address is the source I is from the source. Then the destination is for the destination IPv4 address. So the IPv4 has a limitation. So it says here that IP address depletion. IPv4 has a limited number of unique public IPv4 addresses available. So the limitations of that is the IPv4 has a limited unique IPv4 address. So we all know that IP address should be always unique for each end devices and different uh, and different. So we all know, yes, the IP addresses of the uh, devices should be um, unique. So it says here that uh, the IPv4 has a limited number only. Then internet routing table expansion. A routing table is used by routers to take to make best path determination. As the number of servers connected to the internet increases, so too does the number of network routes. This IPv4 consumes a great deal of memory and processor resources on internet. So um, as the number of servers connected to the internet increases, so it will be consume a lot of more small memory. So that's why that is the limitation also of the IPv4. Then lack of end-to-end connectivity. The network address translation or the NAT is a technology commonly implemented within IPv4. NAT provides a way for multiple devices to share a single public IPv4 address. However, because the public IPv4 address is shared, the IP address of the IPv4 address of an internal network host is hidden. This can be problematic for technologies that require end-to-end connectivity. Because they are sharing the IPv4 addresses, so it will lack of end-to-end connectivity because they share the IPv4. Then, so I said before the limitation, so that's why we are now introducing the IPv6. So the IPv6 has up to undecillion. So it says here that in the early 1990s, the Internet Engineering Task Force, or the IETF, grew concerned about the issues with the IPv4 and began to look for a replacement. So the IPv6 is the replacement for the IPv4. So this activity led to the development of IP version 6, or the IPv6, overcomes the limitations of the IPv4 and is powerful enhancement with the features that better suit current first-ball network demands. So because of the limitations of the IPv4, so they are now introducing the IPv6. So improvements that IPv6 provides include increased address space. So in IP, so it says here that in IPv6 addresses are based on 128 bits. So it has a 128 bits hierarchical addressing. So compared to the IPv4 that only has a 32 bits, so it's a lot bigger in address space. Then improve packet handling. So the IPv6 header has been simplified with fewer fields, so it becomes more easy in the IPv4 and less complexity. Then eliminates the need for NAT. So I said a while ago the about of the NAT 10, with such a large number of public IPv6 addresses, NAT between a private IPv4 address and a public IPv4 is not needed. So it says here that IPv6 address space provides one or the 340 undecillion addresses, which is roughly equivalent to every grain of sand on Earth. So it has it's more bigger size compared to the IPv4. Then the encapsulating IPv6. So let's focus on this diagram. So the violets are the field name kept from IPv4 to IPv6. So the version is still the same, and then the source address and the destination address. So it keeps from IPv4 to IPv6. So then the next one is the name and position change in IPv6. So they change the type of service and the total length, time to live and the protocol. Then fields not kept in IPv6. So they remove it in the IPv6. They eliminated the IHL, the identification flags, fragments of set, header checksum, options, and the padding. So this one, the IPv6 header. So the first one is field name kept again. So the version also and the IPv4. Then name and position change in IPv6, the traffic, class, payload, length, next header, and the hop limit. Then the new field, so they have now the flow label. That this flow label, we cannot locate it in the IPv4. Then the last figure is this one. So they have the IPv6 advantages. So the first one is simplified header format for efficient packet handling. So they remove the NAT. So that's why it is a simplified header format. So then larger payload for increased throughput and transport efficiency. So I said a while ago that the IPv6 has 340 undecillion. So it has a lot bigger than the IPv4. Then hierarchical network architecture for routing efficiency, auto configuration for addresses, elimination of need of for network address translation between the private and the network addresses. So the IPv6 packet header. So the version is this field contains 4-bit binary. So same as the IPv4, so they also 4-bit binary value set. Then the traffic, this traffic class. So this 8-bit field is equivalent, this one, is equivalent to IPv4 differentiated services. So they just changed the name. Then the flow label, this one is the new. So suggested 20-bit field suggests that all packets with the same flow label receive the same type of handling by routers. Then the payload length. This 16-bit field indicates the length of data portion or payload of the IPv6 packet. So this one is for the length. Then the next header, 8-bit field is equivalent to the IPv4 protocol field, so they also changed the name. So in IPv4, it calls the protocol field. Then the hop limit, the 8-bit field replaces the IPv4 TTL or the time to leave field. So they also changed the name. Then the source IP address is just the same. It is identifies the IPv6 address of the sending host, and the destination is the identifies the IPv6 address of the receiving host. This one is the sending, and this is the receiving host. So the default gateway routers routes traffic to other networks, has a local IP address in the same address range as other hosts on the network, can take data in and forward data out. So the default gateway is the network device that can route traffic to other network. It is the router that can route traffic. So the default gateway is we usually use it in the when we are configuring the router. Like for example, we will configure a router and we will put an IP address. So the IP address that we use is the default gateway of the PC that are connected to the routers. And next one, using the default gateway. So I said it that it is the IP address of the router is using the default gateway of the PCs, the PC that are connected to the router. Host routing table. So on a Windows host, the route print or the netstat -r command can be used to display the host routing table. So we will just put this command and the routing table uh, will will display. So router packet forwarding decision. Directly connected routes. So it is simple because it is directly. These routes came from the active router interfaces, so they are directly connected. Then the remote routes, so the routes come from the remote networks connected to the routers. It is a remotely, then the default route. Like a host, routers also use a default route as a last resort in there. No one route and desired network in the route. So default. So it is also what they use. A router is a computer. So the branch teleworkers, small businesses, and medium-sized branch sites, including Cisco Integrated Service Routers or the ISR and the G2 or the second generation. So the branch, so these are the Cisco routers are designed to address the needs of many different types of businesses and networks. So the teleworkers can also in the small businesses. Then the one large business, so it can also in the large business organization and enterprise, including the Cisco Catalyst series switches and Cisco aggregation service routers. Then the service provider, large service providers include the Cisco ASR, Cisco CRS, Dash 3, Carrier routing system, and 7600 series routers. Routing memory. A router has access to volatile or non-volatile memory storage. Let's start with the RAM. So the RAM is the random access memory. So in this one, so if your data is stored in RAM and your computer turned off, so the information or the data will be deleted or will be lost. And in the ROM, so this non-volatile memory is used to store crucial operation instruction. So it is for the crucial operation instruction. So uh, you turn on or even you turn off the computer, the data will still remain in the ROM and also in the NVRAM. Uh, it will be permanent storage. So it's like in the startup config. Then the flash, this is non-volatile computer memory storage. It is also for permanent storing of data. Connect to a router. So this one, enhance, label, then compact flash slot. So this one, then console ports. So this one and this one, the console ports. This one is for the USB, and then this one are gigabit Ethernet. These two, the gigabit Ethernet, and lastly the auxiliary. Boot set file. So both Cisco routers and switches load the iOS image and startup configuration file in the RAM when they are booted as shown in the figure. So this one is the figure. So they have here the flash, the iOS image, then they will go to RAM, and this one is the NVRAM, the startup config, then load to startup config to running config. So basic switch configuration steps. So uh, this one figure is when you will uh, configure a switch. So to configure a device name, so you will use the host name space the host name that you want. Then to secure the user exec mode, so the line console 0 because in programming we started counting at 0, so it means that it is first, or then the password, and then the password that you will put, then you will put login. And then to secure remote telnet or the SSH access, so the line BTY 0 space 15 because 0 to 15 is because it has a 16 port, so 0 to 15, so it also starts in 0. Then the password again, then the password just like you put in the user exec mode, and then log in. Secure privilege exec password is enable secret, then anything password that you want. So it is since it is already in a enable secret, so uh, it is already encrypted. Secure all passwords in the config file. So since that the user exec mode and the password in the remote telnet SSH is not yet uh, encrypted, so you will use the command service password encryption to encrypt all the passwords. Then provide legal notification, so banner MOTD, and then the delimiter or the hashtag sign, and then your message or like for example warning authorized person only, then the delimiter also or the hashtag. Next one is configure the management SVI, so you will type the interface VLAN 1, then IP address, then the IP address of you will put in the switch and the subnet mask. Then the no shutdown is for the saving. Then save the configuration. So copy running config. So what you all configure is stored in the running config. So in the running config, if the computer turns off, so it will be lost or deleted. So to save that, so we will use the copy running config startup config. So router interface configuration task. So configuring a router is just like configuring a switch. Interface, they type the description, then the text, then the IP address, then the IP address, and then the subnet mask, and then no shutdown for saving. So just like this one, the interface gigabit internet 0/0, and then the IP address, then this one is the subnet mask, then the description, this one is the description, then the no shutdown for saving. So configure the IPv4 address as 192 with the subnet mask. So we'll try this one. So enable first. So let's try the interface gigabit ethernet 0/0. Let's try. So let's try show. So it should be configure terminal. After we do a configure terminal, so we'll now put the interface. So let's try the interface gigabit ethernet. So this one is our answer. So the interface gigabit ethernet 0/1, and then the IP address is this one, and then description LAN-11, then no shutdown. So configuring LAN interfaces. So let's try this one. So configure IPv4 address as 192.168.10.1 with a subnet mask of 255.255.255.0, describe the link as LAN/10, then activate the interface. So let's try this one. The first is configure terminal, and then we'll put the interface gigabit Ethernet 0/1, 0/0. Let so configuring LAN interfaces. So configure the gigabit Ethernet 0/0 and interface. Configure IPv4 address as 192.168.10.1 with the subnet mask of 255.255.255.0. Describe the link as LAN-10, then activate the interface. So let's start with the configure terminal, and then the interface gigabit Ethernet Ethernet 0/0, and then the IP address of 192.168.10.1, and then the subnet mask 255.0, and then the description, so will be description, then the LAN dash 10, and then the no shutdown code save. So it must be complete the no shutdown. So that's all for this one. Just type this one. Show IP interface brief. So if you type that, so this one is the example. Default gateway for a host. For an end device to communicate over net, must be configured the correct IP address. So, as I said a while ago, so the IP address for this one is the 192.168.10.0. So this one, the PC1 and the PC2, their default gateway is the 192.168.10.1. And then also, the PC3 and PC4, this one is their default gateway. So that's all for this video. Thank you for watching.